Hi class, let's go over some examples of some exponential forms or powers where my base is negative. Okay, so for my first example, I have negative 5 squared. Now negative 5 squared, is my base going to be 5 or negative 5? In this case, my base is actually just going to be 5. So the rule is pretty much if the negative is on the inside of the bracket, um, then the negative is a part of my base. But if the negative is on the outside of my bracket, then the negative is not a part of my base. So my base right now is just 5 because the negative is not on the inside of my brackets. So I'm simply just going to write 5 for a base. My exponent is 2 because it's 5 to the power of 2. And now what this negative does is it's simply repeated multiplication. Yeah, obviously, but then the negative goes on the outside of the repeated multiplication. So in this case, I have 5 squared. My base is 5, my exponent is 2, so that means I have 5 times 5. So I'm simply going to write 5 times 5 here. Now, after I compute 5 times 5, would you agree? I end up getting 25. However, there's a negative that exists outside of that 25. That negative is going to end up multiplying to that 25. So my final answer in standard form should be negative 25. A better way to explain this is this. Essentially, for the negative 5 squared, that negative in front is actually an invisible negative 1. So I actually have an invisible negative 1 multiplying by 5 squared. If you remember order of operations, right, which is bed mass here, I always want to solve what's in the brackets first, then I solve what's in the exponents, then I solve division or multiplication going from left to right, and then addition and subtraction going from left to right, right? So in this case, if you look at this question where there is technically an invisible negative 1 there, well, I'm not multiplying 5 by negative 1 first because of order of operations. I look for my brackets first. I don't see any brackets, or I do see brackets, but I can't solve what's in the brackets, which is the invisible negative 1. So I move on to exponents, and I can solve what I have for the exponents here. This is simply 5 squared. So that's why I simply just leave that invisible negative 1, and I solve for my exponent. 5 squared is just 5 times 5. So now I simply have an invisible negative 1 multiplying by 25. And now I can apply my division or multiplication rule, which comes third. So in this case, negative 1 times positive 25 is negative 25. And that's the reason why if I have negative 5 squared, the base is simply 5, and I simply just multiply 5 by itself, however many times the exponent tells me to, and I just leave the negative on the outside and apply it right afterwards. Now, let's go over an example that's a bit different. I'm going to use green for this one. Let's go over negative 5 squared. Now, in this case, remember what I said. If the negative is on the inside of the brackets, it is simply included into my base. So my base is going to be negative 5 in this case. And my exponent is 2. Now, as for repeated multiplication, I'm simply going to write negative 5 because it's just my base times itself. And in this case, times itself 2 times because my exponent is 2. So I'm simply going to have negative 5 times negative 5. Okay? Now, negative 5 times negative 5 is just going to be positive 25 because two negatives make a positive. So my final answer in standard form is simply going to be 25. Okay, great. Now let's go over another example. Let's use a purple marker for the rest of this. Negative 2 to the power of 6. In this case, since negative 2 is inside my brackets, my base is simply negative 2. And my exponent is 6. Now, this would simply be negative 2 times itself 6 times. So negative 2 times negative 2. I'm going to run out of room in this rate. Times negative 2 times negative 2 times negative 2. Let's make another negative 2 here somewhere. Times negative 2. Basically, I'm trying to multiply negative 2 times itself 6 times here. I just ran out of room here. Basically, all you need to know for this type of question is this. If you even ignore the negative, just what's 2 times itself 6 times? In this case, okay, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times another 2 is 64. So my final answer should be 64. Now we just have to know if that's positive or negative. So I have negative 2 times negative 2, which is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Positive 16 times negative 2 is negative 32. Then negative 32 times then negative 32 times negative 2 is positive 64. Now, one way to know, one rule that I like to show you guys is this. If you have a negative number inside of a bracket and it's to an even exponent, your answer is always going to be positive. It's always positive. And if you had a negative number, right, and it's inside of a bracket and it's to an odd exponent, your answer is always going to be negative. Those are the rules that I like to use to kind of think about this. So since this is negative 2 to the power of 6, 6 is an even exponent. So ignoring my negatives, if I simply just computed 2 to the power of 6, I got 64. I'm just going to say my final answer is positive because I have a negative exponent to an even, I have a negative base to an even power. Okay, let's move on. I have negative 2 to the power of 3. In this case, we talked about it. If the negative is not inside the bracket, then my base is simply just going to be 2. I'm going to ignore the negative here, okay? This is 3, so my exponent is 3. So that 2 just lies right outside. And then I'm simply going to compute 2 times 2 times 2 3 times. Now 2 times 2 times 2 is 8, and that negative still exists. So I'm going to write it as negative 8. Okay, great. Now I have negative 2 to the power of 4. Once again, since negative 2 is inside of my brackets, I'm simply going to write my base as negative 2, and my exponent is 4. And this is simply going to be negative 2 times negative 2 times negative 2 times negative 2. Yeah, times negative 2. All right. So in this case, that looks really bad. I'm just going to erase that and write it again. Times negative 2. All right, perfect, much better. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16. Since my exponent is an even exponent, I'm simply going to say my answer is positive and leave it as 16. But if you want proof, let's compute it. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16 because I have a negative times a negative at the end. Okay, let's compute this one. Okay, now I have, and this is an interesting one, my base is going to be negative 3 because I have negative 3 inside of my brackets, and it's to an exponent of 3. But because I have this negative on the outside, I have to make sure I am cognizant of it and leave it there. Now I'm simply going to compute negative 3 times itself 3 times. Now, okay, and I'm going to close the bracket. Now let's think about this. Negative 3 times negative 3 is simply going to be positive 9, and then positive 9 times negative 3 is simply going to be negative 27. So I'm going to have negative 27 here. However, that negative on the outside is going to apply to my negative 27. And so it's essentially an invisible negative 1 times a negative 27. So my final answer should be a positive 27. But let's kind of show more work for this and kind of prove it. So I'm going to use brown to kind of show this. Let's show a little bit more work for this. So essentially I have negative 3 cubed. And this is going to be negative 3 times negative 3 times negative 3. But, however, we talked about this. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Remember, this is actually a negative number with an odd exponent. So it doesn't matter like how I do this. I could have just said 3 times 3 times 3, got an answer, and simply just let that answer be negative, because any negative number with an odd exponent will always end up being negative anyways. So what I'm going to have here is I'm going to have a negative 27 on the inside. Now we talked about this. This negative is actually an invisible negative 1. So I can simply take that invisible negative 1 and multiply it by negative 27. And because two negatives multiplied together get a positive, my final answer is simply going to be 27. Positive 27. Okay, great. So let's go over our last example. In our last example, I have negative 1 to the power of 4. Since negative 1 is on the inside, my base is negative 1, and my exponent is 4. So in this case, let's compute this. I have negative 1 times negative 1 times negative 1 times negative 1. In this case, negative 1, negative 1 times negative 1 is positive 1, positive 1 times negative 1 is negative 1, then negative 1 times negative 1 is positive 1. But again, remember, you can always just use this rule. A negative number to an even exponent is the answer is always going to be positive anyways. So in this case, you could have just computed it as 1 times 1 times 1 times 1, and then just let it be positive. And hopefully that helps give you some examples of how to solve for powers or exponential forms where the base is negative.